Sketch the graph of f of x equals 0.4 times 3 to the x. State the domain, range, and asymptote. So we can think of this function, 0.4 times 3 to the x, as a transformation of the graph of 3 to the x. So let's start there. Create a table for 3 to the x. All right, so I'll start with the 0. If my input is 0, 3 to the 0 is 1. 3 to the first power is 3. And 2, 3 to the second power is 9. Remembering that negative exponents mean to use reciprocals. 3 to the negative first power is 1/3, and 3 to the negative second power is 1/9. And plotting those points, let's just use a scale of 1s on the axes. So I've got -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9. And so then drawing that curve, we see we have an increasing exponential function, as expected since the base is greater than 1. All right, so now let's consider the actual function we were looking for, 0.4 times 3 to the x. So hopefully remember from previous topics that if we have a known function and we multiply it by a constant, we call that maybe a scale factor. And if that factor is greater than 1, we get a vertical stretch of the curve. And if that number is between 0 and 1, we get a vertical compression of the curve. And so here we have a compression. Now for the table, it's really just a matter of taking those previous outputs and multiplying them by 0.4. All right, so some of these are relatively easy. 0, if my input is 0, 1 times 0.4 is 0.4. 3 times 0.4 is 1.2, and 9 times 0.4 is, what, 3.6? Now the other ones, I'll admit, I'm gonna have to do those on a calculator. Let's see, so 1/3 times 0.4, 1/3, and let's multiply that by 0.4, and so that's 0.13. So I've got the point -1, and then 0.13, and let's see, 1/9, and multiplying that by 0.4 is 0.04 roughly. And so what's happened is, in a sense, all of these points are being compressed, right? In a sense, they're kind of getting closer to the x-axis, right? So this point that was at 2, 9 has now been compressed to 2, 3.6. That's about there. 0.13 has been compressed to the point 1, 1.2. 0, 1 has been compressed to 0, 0.4, and so on. And so we get the same shaped curve, just compressed. And so we have that curve in blue is 0.4 times 3 to the x. Domain, range, and the asymptote. All right, so domain, same as the base function. The base function 3 to the x has domain of all real numbers, and so does our transformed function. -infinity to infinity in interval notation. The range of the function. Okay, so remember it's asymptotic here. It's going to get closer and closer to the x-axis as my x values become further negative. So then the range is from 0 to infinity. The asymptote, and we just drew it, the asymptote is a line, and in this case it's the line y equals 0.